Okay, everybody, so this is going to be a little bit of an intro tutorial for our third R page assignment for chapter 10. I just wanted to make sure that if you get to the problems and you had no idea what was going on, that you could see one for yourself. So I am going to do part A for you. So there's some free homework points. So you better at least have part A done. But on question number 89, part A, it asks you, what is the percent composition of PbO2? Okay, so part B is a different substance, C is a different substance, but it's all the same question. What is the percent composition? Well, when you are looking for percent composition, what that really means is the percent of each element by mass. Remember, that's key. It has to be by mass. This is not 33% lead and 66% oxygen. It's a 1-to-2 ratio of atoms, but not of mass. Okay, so you have to do the calculation based on mass. All right, so here's how we do that. We take our substance, PbO2, and we add up using the periodic table what this substance weighs. So you find your elements. If you see lead here, it has a mass number of 207.2. Okay. And we have 2 oxygens. Each oxygen is 16.0, so altogether 32.0 when you add those together. And then we add them and we get our total, okay? So our total mass here is 239.2 grams. Grams per mole, grams, whichever, okay? But to get the percent composition of the compound, I need to take each piece, put it over the total, and then multiply by 100 to change that value into a percentage, okay? So we get 207.2 over the total mass, 239.2 times 100. This will give me the percent lead, okay? And then we do the same thing for oxygen. 32.0 over 239.2 multiplied by 100, and we'll get our percent oxygen, okay? When we do that, adjusting for correct sig figs, this one will end up with 4 sig figs. We're going to get 86.62% lead, okay? And this one will only have 3 sig figs because of that 32.0. So we'll end up with 13.4% oxygen. Now, some of you might be like, well, I have an easier way. I could just find the percent lead and then do 100 minus 86.62 to figure out the percent oxygen. You're right, you could do that. As long as you show your work, I'm okay with it. But here's one problem with that method. If you mess up the first one, you also get the second one wrong. Whereas if you do it this way, you can answer check by adding your numbers together, and it should be really close to 100%. It might not always be exactly 100% because of sig fig differences here, but when we add these two together, we're going to get really, really close to 100%. I think it's 100.02%, okay? So I think you should use it as an answer check to try and see if these all equal close to 100% instead of just automatically assuming that you did the first problem right, because we're humans, we make mistakes. Okay, so 89 is easy. Now we're going to go on to number 90. Number 90 matches number 89. Okay, so number 90, part A, let me just get a new board here, scoot this over so we can still see it. I'll bring it back in when we need it. Okay, so number 90, part A, says if you have a 63.8 gram sample of PbO2, how many grams of that are lead? Okay, how many grams are lead? How many grams are lead? Okay, well, this is maybe where you go, oh my gosh, I have no idea. Okay, here's what we do. I'm going to do it as a conversion. There is more than one way to do this, but I'm going to do it as a conversion, okay? Always start with what we're given in the problem. So 63.8 grams of PbO2. All right, set it up. Now, one thing I do know about this substance from number 89 is 86.62% of this substance is lead, right? And percent means out of 100. This means 86.62 grams of lead would be in a 100-gram sample of this compound. Well, I want the compound to cancel. So I can do 100 grams of the compound, PbO2, contains 86.62 grams of lead. Remember, this number is the percent lead in the compound that I calculated in number 89A, 86.62% lead right here. All right. So once I do this, my grams of PbO2 will cancel. And when I multiply, divide by 100, I'm going to end up with grams of lead as my units for the answer, which is what I'm looking for. So that's good. Okay. So when we multiply this across, divide by 100, we're going to end up with 53.3 grams of lead. Okay. Alternatively, if you are used to using percentages and finding percentages of things, you will know that we will just take, so okay, if this makes sense to you, stick with it, okay? But if you don't like it, you can always take a percentage, turn it into a decimal, which means divide it by 100. So you're gonna go like this, right? Moving it over 2 spaces, 0.8662 times your value, 63.8, will give you 86.62% of 63.8. That's what this is doing. And it will give you the same answer, that 53.3 grams of lead. So you can always change your percentage to a decimal, multiply by your sample size, and that will give you the grams of that element. Okay, 2 different methods, same result. Good luck with the rest of the problems. Don't forget to do all of them all the way through H. Yes, we do want you to do all of them so that you definitely know how to do this when we get to our quiz. Thanks, guys. We'll see you guys in class. Reach out if you need help. Always, always reach out.